Hey guys, it's Mrs. Saucetta. I'm here to show you how to complete your density lab, depending on if you're an A day or B day. A B date's February 8th through February 10th or February 9th through February 11th density lab. So you had calculated density when we were doing our mineral identification lab. Density has to do with mass's relationship to volume in a substance. So we're going to do a density lab so you can kind of have some chances to calculate density and get to see that relationship between mass and volume, what causes objects to sink and float. So today we will investigate and calculate density using an online gizmo lab. Click on the gizmo link and log in. So go ahead and click on the gizmo link so you can get logged in. Up here it says log in and enroll. You have already enrolled. So you should have a login, and I told you to make your login your Skyward username and password. So you're going to go ahead and log in. When you get in, it will look a little bit different than mine, but you'll see a list of labs. So you're going to click on the very, very bottom one. It says Density Laboratory. You can go ahead and launch it. And then let's go back to Google Classroom and see what else we need to do. So we clicked on our density laboratory. Now it says open the attached Google slide with your name and follow the instructions to complete the lab. So we're going to open our Google slide. This is our Gizmo density laboratory sheet. So first thing you're going to do is a little bit of warm up, some prior knowledge. Go ahead and anything that you think will float, drag into the circle. So like we know a boat floats, or else it wouldn't be a boat. So you put the boat in the little circle, and you can make it smaller so it all fits. After you're done sorting these, I want you to think about why do some objects float while others sink. So you can go ahead and pause the video while you do that, and then unpause the video so you can check and see if your answers are correct. So go ahead and pause. So you've already separated your items. So things that will float would be our cruise ship, our beach ball, of course, because that's filled with air, but surprising one, Saturn will actually float. And now the rock, some rocks float and some rocks don't, but we'll keep this one out because most rocks will sink, but not all of them. So why do some objects float and why others sink? So this has to do with density, an object's density, how much mass in comparison to how much volume or space it takes up. So it says warm up. The density laboratory gizmo allows you to measure a variety of objects, then drop them in water and to see if they sink or float. It says why milliliters are used to measure liquids volumes. Centimeters cubed is used to measure a solid's volume. So an object's mass is the amount of matter it contains. Mass can be measured with a calibrated scale like the one shown in the gizmo. Drag the first object onto the scale. This is object 1. What is the mass of object 1? So we're going to go over here. You see object 1. I put it on our scale. It gives you mass, 19.5. Go ahead and fill that out. 19.5, but don't just put 19.5, 19.5 grams. An object's volume is the amount of space it takes up. The volume of an irregular object can be measured by how much water it displaces in a graduated cylinder. What is the initial volume of the water in the cylinder? So we're going to see the initial volume right now. The volume is at 400 milliliters. So milliliters is how we measure a liquid's volume. So it's 400 milliliters before we put anything in there. It's 400 milliliters of water. Now it says place object 1 into the cylinder. What is the volume in the cylinder now? So we're going to grab object 1 and put it in the cylinder. So it was 400, but now that I put the cylinder in there, now that I put the object in the graduated cylinder, the volume in our cylinders increased. So it was 400 milliliters, but now that we've dropped the object in there, the volume is 414.2. So what is the volume in the cylinder now? 414.2 milliliters. And then it says, well, what is the volume of the object then? So the volume is actually the difference. If you were to take 414.2 and subtract 400, that would give you the volume. We call this water displacement. But it actually does the math for you. If you notice up here, 14.2, and it gives you the new units because we're talking about a solid. So we're not going to do milliliters. This time we're going to do centimeters cubed. So 14.2 centimeters cubed. So 14.2 centimeters cubed. I'm going to copy this little 3 because I don't know how to make that on my own. And I'm going to paste that down there. So we got our 3 exponent. So that was a warm-up just to make sure you know how to measure mass and measure the volume. Now I would like you to try to turn this into a density problem real quick. So just for extra warm-up. So density equals mass divided by volume. So you need to take your mass and divide it by the volume. So D equals M divided by V. Just like our speed problem, speed equals distance over time. Density equals mass divided by volume. So it's very similar. So we're looking for D. We have our mass, 19.5 grams. We're going to divide that by our volume. And I know this might be confusing, but these are not our volumes. This is the volumes in the cylinder, right? This is the volume of the object we put in the cylinder. So we're going to use that volume of the object, which is 14.2. We need that unit, centimeters cubed. Paste that in there. Now you are allowed to use a calculator. We're going to go ahead and we can Google calculator. And so we're going to take our mass, 19.5, and divide that by our volume, 14.2. 19.5 divided by 14.2. So this gives us 1.37. We can just get the first 2 decimal points would be fine. So our density, density equals 1.372. But it's not just 1.372, it's 1.372 grams per centimeters cubed, because you always need your units. If you don't give me your units, I don't know what you're talking about. So is it 1.37 miles, $1.37? So you need to make sure you give me units or else your numbers don't have any meaning. Okay, so I just wanted to make sure that you could measure mass, measure volume, and use that to calculate density. If you can't do that, then you're going to have a hard time doing the lab. Okay, so next we're just going to focus on whether these objects sink or float. We're going to take the mass and the volume of each object, and we're just going to write down whether it sinks or floats. So and we'll come back and do the density at the end for each of these. So let's just collect our data first, and then we'll do our calculations next. So we actually already did the mass and volume of object 1, but we didn't see if it floats or sinks. So first thing we want to do though is get the gizmo ready. So we're going to drag object 1 back to the shelf, check that the liquid density is set to 1, and then we're going to go through them all. So let's make sure our water is set to 1. We can go ahead, we already did this, right? But we'll put them back up here. So we already know 1's information. So we're going to go ahead and transfer that over here. But we don't know if it floats or sinks yet, so that's what we do need to check because we didn't do that part. Okay, so now let's grab object 1 and just drop it into the water. Make sure it's at 1 now, okay? And this is sinking. So we're going to go over here and we're going to write that it sinks. Now your job is to go through the rest. I'll show you one more time with 2 what to do. And then you're going to go through and do the rest on your own. So object 2, we want the mass, 11.1 grams. Make sure you have your units, 11.1 grams. Our volume, so remember the volume of the cylinder right now of water is 400 milliliters, but when I drop this in, it takes me up to 409.7. So there's a difference. If you were to take 409.7 and subtract 400, the difference would be 9.7 centimeters cubed. And you cannot copy and paste these in, okay? You have to type them. 9.7 centimeters cubed. 9.7 centimeters, and I'm going to copy my cubed. Maybe. And now we're going to see if it sinks or floats. This one also sinks. And so as you're going through, finishing this out, I want you to kind of take note of which objects are more likely to sink. Are they the ones with the larger mass or the ones with the larger volumes? So as you're collecting data, it's very important that you're interpreting and analyzing that data as you go and try to find some kind of patterns, okay? So you go ahead and fill out that table. You can press pause on the video until you're done. So I press pause and fill that out. Now, once you have done that, you're going to analyze. You're going to look for patterns in the data. You've completely filled out your data table. Now you need to look for patterns. So does the mass alone determine whether an object floats or sinks? So look at your chart of all your data and decide, does the objects with the largest mass always sink? Or do they always float? Or does it have to do more with the volume? Does the volume alone determine if it floats or sinks? So you have to determine, is one of those alone, and then explain what you're thinking. Now you're going to look at this pattern in your data. You need to compare the mass and the volume to each other. And then what do you think the relationship between mass and volume is of all the floating objects? So every object that floats, you could go through and highlight if you wanted to. So all my sinking objects I can make blue, and then all my floating objects I can make yellow, and then we could decide what is the relationship between mass and volume of the floating objects. Do they have larger volumes on the floating objects? Do they have larger masses on the floating objects? So go ahead and explain that relationship, and then look at the sinking objects and then find out the relationship between the mass and volumes on the objects that sink. After you do that, it's time to calculate your density. So to calculate your density, it says the density of an object is its mass per unit of volume. Dense objects feel very heavy for their size, while objects with low density feel very light for their size. So you could have two objects that are about the same size, but that doesn't mean they feel just as heavy. These are about the same size, but this object is much heavier.